NFPA 70E, the standard for electrical safety in a workplace, mandates arc flash warning labels for electrical equipment under specific conditions. These conditions are firstly, when the potential for an arc flash exists, secondly, when personnel are likely to be exposed to the arc, and thirdly, when a qualified electrical worker deems a warning label necessary. When considering the placement of warning labels, switchboards, panel boards, and switchgear require labels on the outside of the door or housing. Circuit breakers and fuse switches need labels on the face of the device. Motor control centers should have labels on the door or housing. Transformers require labels on the tank or housing. For other electrical equipment, the placement is determined by a qualified electrical worker. However, there are exceptions to the labeling requirements. Labels are not required for equipment that is isolated or de-energized. Equipment located in an electrical closet or other restricted area also does not need labels. Similarly, equipment that is out of reach or difficult to access, and equipment that is not likely to be worked on hot are exempt from labeling. Beyond the specific NFPA 70E requirements, there are additional considerations for employers when determining where to place arc flash warning labels. Risk of exposure is a key factor, prioritizing labeling for equipment that poses a high risk of arc flash. Frequency of access is another important consideration. Equipment that is frequently accessed or worked on should be prominently labeled. Visibility is crucial. Labels should be placed in a location where they are readily visible to personnel. Durability is essential. Labels should be made of durable materials that can withstand the elements and harsh conditions. For best practices, standardized arc flash labels that meet NFPA 70E requirements should be used. Employees should be trained on the meaning of arc flash warning labels. Labels should be regularly inspected for damage or deterioration and replaced as needed. Consider using additional warning devices, such as signs, barriers, or audible alarms, to further enhance arc flash hazard awareness. In summary, arc flash label placement should adhere to NFPA 70E, considering the potential for arc flash, likely exposure of personnel, and the judgment of qualified electrical workers. Proper placement on switchboards, panel boards, switchgear, circuit breakers, fuse switches, motor control centers, and transformers is vital. Exceptions exist for isolated, de-energized, restricted, inaccessible, or rarely worked on equipment. Employers should also consider the risk of exposure, frequency of access, visibility, and durability when determining label placement. Best practices include using standardized labels, training employees, regular inspections, and additional warning devices. Prioritize equipment based on risk assessment, focusing on high-risk areas and frequently accessed components. Ensure that labels are easily seen and made of materials that can withstand their environment. The goal is to create a safer working environment by providing clear and effective warnings about potential arc flash hazards. Remember that the specific details on the labels, such as the voltage, arc flash boundary, and personal protective equipment requirements, are crucial for worker safety. Regular audits and updates to the arc flash risk assessment are necessary to keep the labels accurate and effective. The arc flash boundary is the distance from the potential arc flash source within which a person could receive a second-degree burn. The incident energy is the amount of thermal energy that a person could be exposed to during an arc flash event, usually measured in calories per square centimeter. The personal protective equipment, or PPE, is the clothing and equipment that workers must wear to protect themselves from arc flash hazards. This may include flame-resistant clothing, gloves, face shields, and helmets. The hazard risk category is a classification system that helps determine the appropriate level of PPE required for a particular task. NFPA 70E provides guidance on how to determine the hazard risk category for various electrical tasks. The working distance is the distance from the potential arc flash source to the worker's face and chest. This distance is used to calculate the incident energy and determine the appropriate level of PPE. A qualified person is someone who has the skills and knowledge related to the construction and operation of electrical equipment and installations and has received safety training to recognize and avoid the hazards involved. The arc flash risk assessment is a process of identifying potential arc flash hazards, evaluating the likelihood and severity of an arc flash event, and determining the appropriate protective measures. A single-line diagram is a simplified representation of an electrical system that shows the major components and their connections. This diagram is used to help identify potential arc flash hazards and calculate the incident energy. Short circuit studies are performed to determine the magnitude of fault currents that could flow in an electrical system during a short circuit event. This information is used to calculate the incident energy and determine the appropriate level of PPE. Protective device coordination studies are performed to ensure that protective devices, such as circuit breakers and fuses, are properly coordinated to minimize the duration of an arc flash event. Grounding is the process of connecting electrical equipment to the earth to provide a path for fault currents to flow back to the source. Proper grounding is essential for reducing the risk of electric shock and arc flash. Overcurrent protection is the use of circuit breakers and fuses to protect electrical equipment from overloads and short circuits. Proper overcurrent protection is essential for reducing the risk of arc flash. Maintenance is the process of inspecting, testing, and repairing electrical equipment to ensure that it is in safe operating condition. Regular maintenance is essential for reducing the risk of arc flash. Training is the process of educating workers about the hazards of arc flash and how to protect themselves. Proper training is essential for reducing the risk of arc flash injuries. Lockout-tagout procedures are used to de-energize electrical equipment before it is worked on. Proper lockout-tagout procedures are essential for preventing accidental energization of equipment and reducing the risk of arc flash. Personal protective equipment must be regularly inspected and maintained to ensure that it is in good condition and provides adequate protection. Arc flash hazard analysis is a detailed study to determine the potential arc flash hazards in a facility, including the incident energy levels and arc flash boundaries. This analysis is typically performed by a qualified electrical engineer. Incident energy analysis is the calculation of the amount of energy released during a potential arc flash event. This analysis is used to determine the appropriate level of PPE required for a particular task. The arc flash boundary is the distance from the potential arc flash source within which a person could receive a second-degree burn. The flash protection boundary is the distance from exposed live parts within which a person could receive a curable burn. The limited approach boundary is the distance from an exposed live part within which a person must be qualified to enter. The restricted approach boundary is the distance from an exposed live part within which a person must have specific training and PPE to enter. The prohibited approach boundary is the distance from an exposed live part within which a person is not allowed to enter unless they have the same protection as if they were in direct contact with a live part. Arc-rated clothing is clothing that has been tested and certified to provide protection from arc flash hazards. Flame-resistant clothing is clothing that is inherently flame-resistant or has been treated to be flame-resistant. Voltage-rated gloves are gloves that have been tested and certified to provide protection from electrical shock. Voltage-rated tools are tools that have been tested and certified to provide protection from electrical shock. Face shields and helmets are used to protect the face and head from arc flash hazards. Safety glasses are used to protect the eyes from arc flash hazards. Hearing protection is used to protect the ears from arc flash hazards. Foot protection is used to protect the feet from arc flash hazards. Grounding and bonding are used to provide a low impedance path for fault currents to flow back to the source, which helps to reduce the risk of arc flash. Electrical safety audits are used to identify potential electrical hazards and ensure that electrical safety procedures are being followed. Electrical safety training programs are used to educate workers about the hazards of electricity and how to protect themselves. Continuous improvement is an ongoing process of identifying and implementing improvements to electrical safety programs. The hierarchy of controls is a system for prioritizing hazard control measures, with the most effective measures at the top and the least effective measures at the bottom. The hierarchy of controls includes elimination, substitution, engineering controls, administrative controls, and personal protective equipment. Elimination involves removing the hazard completely. Substitution involves replacing the hazard with a less hazardous alternative. Engineering controls involve isolating the hazard or reducing the risk of exposure. Administrative controls involve implementing procedures and policies to reduce the risk of exposure. Personal protective equipment is the last line of defense and should only be used when other control measures are not feasible or effective. Arc flash mitigation is the process of reducing the risk of arc flash events. Arc flash prevention is the process of preventing arc flash events from occurring. Arc flash awareness is the process of educating workers about the hazards of arc flash and how to protect themselves. Electrical safety culture is the shared values, beliefs, and attitudes about electrical safety within an organization. A strong electrical safety culture is essential for reducing the risk of electrical injuries and fatalities. The NEC, or National Electrical Code, provides standards for the safe installation of electrical wiring and equipment. NFPA 70E provides standards for electrical safety in the workplace. OSHA, or the Occupational Safety and Health Administration, enforces electrical safety regulations in the United States. The IEA, or Institute of Electrical and Electronics Engineers, develops standards for electrical engineering. ANSI, or American National Standards Institute, develops standards for a wide range of industries, including electrical safety. UL, or Underwriters Laboratories, tests and certifies electrical equipment for safety. CSA, or Canadian Standards Association, tests and certifies electrical equipment for safety in Canada. C, or Conformité Européenne, is a marking that indicates that a product meets the requirements of European Union directives. IC, or International Electrotechnical Commission, develops international standards for electrical engineering. Compliance with these standards and regulations is crucial for ensuring a safe working environment for electrical workers. The selection of appropriate PPE is essential for protecting workers from arc flash hazards. The PPE must be appropriate for the incident energy level at the work location. Workers must be trained on how to properly use and maintain their PPE. Regular inspections of PPE are necessary to ensure that it is in good condition and provides adequate protection. The proper use of insulated tools is essential for preventing electrical shock. Insulated tools must be regularly inspected to ensure that they are in good condition. Workers must be trained on how to properly use insulated tools. Grounding and bonding are essential for providing a low impedance path for fault currents to flow back to the source. Proper grounding and bonding can help to reduce the risk of arc flash and electrical shock. Regular inspections of grounding and bonding systems are necessary to ensure that they are in good condition. Lockout-tagout procedures are essential for de-energizing electrical equipment before it is worked on. Proper lockout-tagout procedures can help to prevent accidental energization of equipment and reduce the risk of arc flash and electrical shock. Workers must be trained on how to properly perform lockout-tagout procedures. Regular audits of lockout-tagout procedures are necessary to ensure that they are being followed correctly. Electrical safety audits are essential for identifying potential electrical hazards and ensuring that electrical safety procedures are being followed. Regular audits can help to prevent electrical injuries and fatalities. Workers must be involved in the audit process. The results of the audit must be communicated to workers and management. Corrective actions must be taken to address any deficiencies identified during the audit. Electrical safety training programs are essential for educating workers about the hazards of electricity and how to protect themselves. Training must be provided to all workers who may be exposed to electrical hazards. Training must be updated regularly. Workers must be able to demonstrate their understanding of the training material. Continuous improvement is an ongoing process of identifying and implementing improvements to electrical safety programs. All workers must be involved in the continuous improvement process. The hierarchy of controls must be used to prioritize hazard control measures. Data must be collected and analyzed to track the effectiveness of electrical safety programs. Arc flash suits are designed to protect workers from the thermal effects of an arc flash. The arc rating of an arc flash suit is measured in calories per square centimeter. The arc rating of the arc flash suit must be greater than or equal to the incident energy level at the work location. Arc flash blankets are used to cover energized equipment and protect workers from arc flash hazards. Arc flash blankets must be made of flame-resistant material. Arc flash barriers are used to isolate energized equipment and protect workers from arc flash hazards. Arc flash barriers must be made of flame-resistant material. Remote racking devices are used to remotely operate circuit breakers and other electrical equipment. Remote racking devices can help to reduce the risk of arc flash injuries. Infrared thermography is used to detect hot spots in electrical equipment. Hot spots can indicate potential problems that could lead to an arc flash. Ultrasonic testing is used to detect defects in electrical equipment. Defects can weaken the equipment and increase the risk of an arc flash. Partial discharge testing is used to detect insulation breakdown in electrical equipment. Insulation breakdown can lead to an arc flash. Power quality monitoring is used to monitor the voltage, current, and frequency of electrical power. Power quality problems can increase the risk of an arc flash. Predictive maintenance is used to predict when electrical equipment is likely to fail. Predictive maintenance can help to prevent arc flash events. Online monitoring is used to continuously monitor the condition of electrical equipment. Online monitoring can provide early warning of potential problems that could lead to an arc flash. Arc flash relays are used to quickly de-energize electrical equipment in the event of an arc flash. Arc flash relays can help to reduce the severity of arc flash injuries. Current limiting fuses are used to limit the amount of current that flows during a short circuit. Current limiting fuses can help to reduce the incident energy of an arc flash. Arc-resistant switchgear is designed to contain the energy of an arc flash event. Arc-resistant switchgear can help to protect workers from arc flash injuries. Zone-selective interlocking is used to coordinate the operation of multiple circuit breakers. Zone-selective interlocking can help to reduce the duration of an arc flash event. Maintenance mode is a setting on some circuit breakers that reduces the amount of current required to trip the breaker. Maintenance mode can help to reduce the incident energy of an arc flash during maintenance activities. High-resistance grounding is used to limit the amount of current that flows during a ground fault. High-resistance grounding can help to reduce the risk of arc flash and electrical shock. Solidly grounded systems are the most common type of grounding system. Solidly grounded systems provide a low impedance path for fault currents to flow back to the source. Ungrounded systems do not have a direct connection to ground. Ungrounded systems can be more susceptible to transient overvoltages. Impedance grounded systems use a resistor or reactor to limit the amount of current that flows during a ground fault. Impedance grounded systems can help to reduce the risk of arc flash and electrical shock. Ground fault circuit interrupters, or GFCIs, are used to protect people from electrical shock. GFCIs trip a circuit when they detect a ground fault. Arc fault circuit interrupters, or SIs, are used to protect people from arc faults. SIs trip a circuit when they detect an arc fault. Surge protective devices, or SPDs, are used to protect electrical equipment from voltage surges. Voltage surges can damage electrical equipment and increase the risk of an arc flash. Transient voltage surge suppressors, or TVSSs, are a type of SPD. TVSSs are designed to protect sensitive electronic equipment from voltage surges. Harmonic filters are used to reduce the amount of harmonic distortion in electrical power. Harmonic distortion can damage electrical equipment and increase the risk of an arc flash. Power factor correction capacitors are used to improve the power factor of electrical power. A poor power factor can increase the amount of current that flows in electrical circuits, which can increase the risk of an arc flash. Load shedding is used to reduce the amount of electrical load on a system. Load shedding can help to prevent overloads and reduce the risk of an arc flash. Emergency power systems are used to provide electrical power during a power outage. Emergency power systems can help to maintain critical operations and prevent disruptions. Uninterruptible power supplies, or UPSs, are used to provide a continuous source of electrical power. UPS can help to prevent data loss and equipment damage during a power outage. Backup generators are used to provide electrical power during a power outage. Backup generators can help to maintain critical operations and prevent disruptions. Automatic transfer switches, or ATSs, are used to automatically switch between the normal power source and an emergency power source. ATS can help to ensure a seamless transition to emergency power during a power outage. Coordination studies are used to ensure that protective devices are properly coordinated. Coordination studies can help to minimize the duration of a fault and reduce the risk of damage to electrical equipment. Selective coordination is a type of coordination where only the protective device closest to the fault trips. Selective coordination can help to minimize the impact of a fault on the electrical system. Time current curves are used to illustrate the tripping characteristics of protective devices. Time current curves can be used to coordinate the operation of multiple protective devices. Short circuit calculations are used to determine the amount of current that will flow during a short circuit. Short circuit calculations are essential for selecting the proper protective devices and ensuring that electrical equipment is adequately protected. Available fault current is the amount of current that is available to flow during a short circuit. The available fault current must be known in order to properly select protective devices. Interrupting rating is the maximum amount of current that a protective device can safely interrupt. The interrupting rating of a protective device must be greater than or equal to the available fault current. Withstand rating is the amount of current that electrical equipment can safely withstand. The withstand rating of electrical equipment must be greater than or equal to the available fault current. Overcurrent protection is used to protect electrical equipment from overloads and short circuits. Overcurrent protection devices include fuses and circuit breakers. Fuses are one-time devices that melt when they are overloaded. Circuit breakers are reusable devices that trip when they are overloaded or short-circuited. Inverse time circuit breakers trip faster as the amount of overcurrent increases. Instantaneous trip circuit breakers trip almost instantaneously when they detect a short circuit. Molded case circuit breakers are commonly used in residential and commercial applications. Insulated case circuit breakers are commonly used in industrial applications. Power circuit breakers are commonly used in high voltage applications. Ground fault protection is used to protect people from electrical shock. Ground fault protection devices include ground fault circuit interrupters, or GFCIs, and ground fault relays. Arc fault protection is used to protect people from arc faults. Arc fault protection devices include arc fault circuit interrupters, or RFCIs. Surge protection is used to protect electrical equipment from voltage surges. Surge protection devices include surge protective devices, or SPDs, and transient voltage surge suppressors, or TVSSs. Harmonics are unwanted frequencies in electrical power. Harmonics can damage electrical equipment and increase the risk of an arc flash. Harmonic filters are used to reduce the amount of harmonic distortion in electrical power. Power factor is a measure of how efficiently electrical power is being used. A poor power factor can increase the amount of current that flows in electrical circuits, which can increase the risk of an arc flash. Power factor correction capacitors are used to improve the power factor of electrical power. Load management is the process of controlling the amount of electrical load on a system. Load management can help to prevent overloads and reduce the risk of an arc flash. Energy efficiency is the process of using less energy to perform the same task. Energy efficiency can help to reduce the cost of electricity and reduce the environmental impact of electricity generation. Renewable energy sources include solar, wind, hydro, and geothermal power. Renewable energy sources can help to reduce the reliance on fossil fuels and reduce the environmental impact of electricity generation. Smart grids are electrical grids that use digital technology to improve efficiency, reliability, and security. Smart grids can help to reduce the risk of power outages and improve the integration of renewable energy sources. The Internet of Things, or IoT, is a network of physical devices that are embedded with sensors, software, and other technologies for the purpose of connecting and exchanging data with other devices and systems over the internet. The IoT can be used to monitor and control electrical equipment remotely, which can improve safety and efficiency. Big data is a term for data sets that are so large or complex that traditional data processing application software is inadequate to deal with them. Big data can be used to analyze electrical system performance and identify potential problems. Artificial intelligence, or AI, is the ability of a computer or a robot controlled by a computer to do tasks that are usually done by humans because they require human intelligence and discernment. AI can be used to automate electrical system operations and improve safety. The cloud is a network of remote servers hosted on the internet and used to store, manage, and process data, rather than a local server or a personal computer. The cloud can be used to store and analyze electrical system data. Cybersecurity is the practice of protecting computers, networks, and data from unauthorized access, use, disclosure, disruption, modification, or destruction. Cybersecurity is essential for protecting electrical systems from cyber attacks. The electrical industry is constantly evolving, and it is important to stay up to date on the latest technologies and best practices. The NFPA 70E standard is updated every 3 years, and it is important to review the latest edition to ensure that your electrical safety program is compliant. There are many resources available to help you stay up to date on electrical safety, including industry publications, websites, and training courses. By staying informed and taking proactive steps to improve electrical safety, you can help to protect workers from the hazards of electricity.